how we're supposed to approach. So they say sketch below is the graph of the function f of x. Ne? And then they say which is given by ax squared plus bx plus c. And then we also have g of x. But they say we have a, which is 0, it's minus 3 is to 0, meaning it's because this is 0, it makes it to be an x-intercept. Ne? But they already said it. They said a and b are the x-intercepts. And then we also have c, which is the y-intercept of f. They're being specific of the graph f. Ne? Yes. And then they're talking about the graph of g passes through the origin. So it passes through here. And then it also passes through the point 1 is to 2, which we don't know where it is. So we suspect which it should be somewhere around 1, because this one they said is 1, and we expect it to be somewhere there because we have 1. Again, we also had 1 at B here. So it should be like parallel with B. They are on the same line as B because it's 1. I think this one is 1 here, and then this one here is also 1. But the only thing that is different between them is that this one has y which is 0, this one has y which is 2. So but they are on the same line. Yeah, they're on the same. They're on the same vertical line. It's parallel to the y-axis. Parallel to the y-axis. Yes, yes. And then they then say first question. Yeah. First question they say we should then. We should use the graph to determine the values of x for which f prime of x greater. So we can write it like this so that we remember. This is m multiplied by y of g. We are talking about the y, but not just the y of g. And then they should give us something which is less than 0, which is going to be what? To be negative. So if we're talking about that, these are the scenarios that we can have. Now we want m. Okay, let's make the m to be read. So we want m, we want y. Ne? So, and then what do we expect? For us to get a negative, we want to get a neg. Let's write it as negative. Ne? So how would a neg occur? The gradient should be negative. And then the y should be what? Should be positive. If this one is negative, this one is positive, then we'll have what? A negative. Another way we can have a negative is this way. This person can be positive. Yes. And then this one should be what? Should be negative. And then it means which we're also going to have what? A negative. A negative, yeah. And then I was thinking to myself, which one is the best one? Which one is the best way to do this thing? But you should understand, as soon as they say gradient, we're no longer looking at this function anymore. But what is it that we're looking for? We're looking for its gradient. And then its gradient, you can check by, there are many ways in which you can do it. Usually I will use the line, and then I thought about it to say, is it a good thing to use the line? Because what I will do, I will go up until to the turning point. I'll just draw a line like this. And then from the turning point, and then this is the gradient number 1 of this line.
So, Mr. My question is that how do we see whether this gradient has a positive or negative?
Yeah, that's what I want. Yeah, so if they say gradient, I'm thinking this way. Now I'm just thinking it, which let's do it together, and then we'll decide which. Original I was using the lines. Yes. And I'm thinking, why can't I say, if I see f prime, I'll just say, since the graph here, I'm looking at this graph here, and then I will check whether it's increasing or decreasing. Yes. If it's increasing, the gradient, not the graph itself, the gradient is positive. So what I will then do something, I will do something like this. I will say this is positive, positive, positive. And then I will want us to remember, I'm not talking about the graph, I'm talking about what? The gradient. Up until I get to the what? To the turning point. The other thing that I could have done, I could have just made a red line. Then the red line will tell me what this thing here is. And then I will use another color for decreasing. Let me use green. So this one is negative, it's negative, it's negative. But you see, what's confusing learners, the way I was doing it, this graph is above the x-axis. So if it's above the x-axis, the graph itself, is positive, but the gradient is negative. So the graph is decreasing here. So where was I? Okay. I was trying to say, I will then say I have negative, 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 negative. So the green represents the negative, yes. And then the red represents the what? The positive. Now, when I go to g of x, it's a different story. I'm going to say that I have the y-axis. I have the x-axis where y is equal to 0. Yes. Now I'm going to look at this graph whether it's appearing above the x-axis or below the x-axis. Because I want the y now. I'm no longer interested in the gradient of this graph. I'm interested in the graph itself. So the way I'm going to write it on, it's going to be something totally different. So blue, it's below the x-axis. It's negative, 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 it's negative. Up until I get here. So what are the critical things here? Number one, you need to have a vertical line here. Because this graph, why, like these are where the changes are happening. I think this graph is changing from being a positive gradient to what, to a negative gradient. So I will have to come and put something here. This is important. It's a vertical line. It's like a critical point.
Yes.
Now, negative, 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 negative. Where is the other change happening? It's happening here at 0. At 0, then we'll put another color. Let's put the black.
But it's there already.
It's positive, 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 it's positive.
Yes.
Now, I'm clear, guys. On the f of x, I'm not talking about the graph, I'm talking about the what? The gradient. On g of x, I'm talking about the y values. The y value can either appear above the x-axis or the y value can appear what? Below the x-axis. So you check both graphs where the changes are happening. In both graphs, those we are going to call them critical values.
Yes.
So critical value number 2 is going to be here. Where do we get this critical value? This one we get it according to G. So this is the critical value of what? Of G. This is the critical value of what? Of F.
X.
So now it created, it has created spaces for us. I want to zoom this thing. We'll come back to it. Okay. Let's try to zoom. No. Okay, I'm supposed to go here. So what I'm doing, okay. Something like this. Okay, sharp. So if you look at this here, it has created how many spaces? There are these spaces that we're going to be working on. Space number 1 is this one.
Yes.
This is space number 1. And then where is space number 2? Space number 2 is in between here.
C and
yeah. So this is going to be space number 2. And then we have space number 3. Space number 3 is this one. So these are the 3 spaces that we are going to be checking in.
Yes.
Yes. So you come and check space number 1. Okay, space number 1. What is happening? We have the other one positive. The other one is what? It's negative. So we want that.
Yes.
And then remember, we have a critical value here. So the x value that is here, this is the person that we're going to be talking to. Because the person can either be this side of the x or it can be this side of the x. That's what we're talking about.
Yes.
So if they're this side of the x, we say they are less than.
Yes.
But now we don't know what is this person. Unfortunately, we don't know. But we can get that person. How to get that person? Remember, I'm given A. I'm also given what? B. Now, what is A and B? A and B are the x-intercept. And then this is an axis of symmetry. This is the axis of symmetry. How do we get the axis of symmetry? We can get it by saying x of the turning point is going to be x-intercept number 1 plus x-intercept number 2 divided by 2, which is the midpoint formula from
analytical
geometry. Through that. That is the honest truth.
Oh, so Mr. Who create the x of the...
Yeah. Now we agree. We don't have the equation. Basically, we wanted to get the turning point. You can't get the turning point if you don't have the equation.
Is there a location for the equation for the x value?
They should be. And the other thing that you could have done, maybe, because we were talking about it, even yesterday we spoke about it. Agree, let's say you couldn't get this thing.
Yes.
And then you could have went on to calculate our values of A and D.
Yes.
And then after that, you go and use the equation to get the turning point if you didn't know this method.
So you're not wrong.
You go down and then you find it there. And then after you found it, then you go back again and then you try to...
straight to the answers. You don't penalize me.
Straight to the answers, Sanjay.
Straight to the answers. Like I say,
no. Here there's a mark for there's no mark for you calculating the x value. I will check. I'm not sure. But I think it will be implemented either way. Plus 1. Yes. So it's -3 plus 1 divided by 2.
Minus 1.
It gives us -1. So we know this point here. We're not interested in the y. We're interested in the x. So the values that are this side in relation to -1, what will you say? Are they bigger than -1 or less than -1? They're less than -1.
Yes.
So we have x, which is going to be less than minus 1. That's the first one. You come and check here with the small space, which is the one that is a problem, because you see here we have green and we have blue, which means the other one is negative. The other one is also what? Negative. Negative and negative, we don't want it.
Yes, but C and B could work for us.
Who?
I don't work.
No, it doesn't work up until you get to the agree. Now this is another space from here to here. This is the one that I was talking about. The one that is space here.
Yes.
It's either in that space it works or it doesn't work.
Yes.
You shift, it doesn't work then. And then you go to this one. If you look at this one it's negative. This one is what? It's positive. Agree, this one is positive, 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 positive.
Yes.
This one is negative, 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 negative.
Yes.
So we can tell them which when x is less than. Because what is the value of x here? The value of x here is what? It's 0. So when x is less than, when x is greater than what? Than 0. And then if they said greater or equals to, I'm sure they can sometimes use about greater or equals to.
Yes.
Then you will include or you will uninclude. But for 4 marks, I think they were going to give us a mark for this thing here. Then they will give us 1 mark for this one, and then 1 mark for it was 4 marks.
4 marks.
It was 4 marks all in all. Are you good, guys?
I want to clarify a similar question related to this. So if I understand that now.
You want to get a similar question to that? Should we go straight to that similar question? Yes.
I wanted to continue.
Huh? Yes.
Can you repeat the part here? X is less than -1.
X is less than -1. This one.
Yes.
Look at this now. You see the red color here. We said the graph.
Yes.
The graph is increasing. Can you see this graph is increasing? So we said since the graph is increasing, the f of x, it means with the gradient, because they were talking, if they say f prime, they are talking about the gradient. They're not talking about the graph itself, but they're talking about the gradient.
Yes,
The
the
graph.
gradient.
Yeah. So the gradient is positive. How do I know the gradient is positive? It's going to be positive because the graph is increasing up until I get to the turning point. And then from the turning point, the graph is going to change direction. Then it starts to go down. It decreases, it decreases, it decreases, it decreases. But if let's say, they were talking about f of x. If they were talking about f of x, I was going to look at the x-axis, and then I was going to say the graph can either appear above the x-axis or below the x-axis. And then I will do exactly the same thing. I will say, where is the graph positive? Where is the graph negative? That one is positive above the x-axis. It's negative below the x-axis.
Yes.
So maybe just to let's erase this one. Okay, but just to explain what you're asking, so here we had the graph increasing, the gradient. That is why when I was writing here in my mind, I was clear to say this positive that I'm writing are not for f of x, but they are for the gradient of f of x.
Yes.
And then up until I get to the turning point. That is why whether the graph was appearing below the x-axis or above the x-axis, I didn't care. And then since there was the graph was changing from being positive to negative, I came here and wrote a vertical line to say this is a critical value. I wanted to know what is x here, because the graph is doing a change, from being increasing to decreasing. It becomes important to us.
Yes.
Sure. And then we ended up having a positive, and then the other graph that we're looking into was the g of x. The g of x, we're not looking at the gradient of g of x, but we're looking at the graph itself. So your mind should switch from there. You should remember on g of x, I'm looking for y. How do you determine whether y is positive or negative? You look at the graph, whether it's appearing above the x-axis or it's appearing below the x-axis.
Yes.
But if we're looking for the gradient, it was going to be simple. We're going to check if the graph is increasing or decreasing. That's all. Let's say for g of x, they said the question was f of prime of x multiplied by g prime of x. Here it means I'm looking at a gradient and a gradient. So that's the question that you should ask first. Am I looking for the gradient or am I looking for the y value?
Yes.
And then how do you know whether the graph is positive, the gradient is positive or negative?